Okay, so in this, we're going to go over an absolute value with no solution. And we're going to graph it and do some checks and just sort of go over the way in which we can identify it. So if we start with this, we're going to isolate the absolute value to one side. So now we have 3x minus 4, and we move the negative or the 12 over, so that's minus 3. So now if we look at this right away, we should know that there is no solution. We have the absolute value of something, which has to be positive, and it says it equals negative 3. So we know there's no solution. But let's just check. So an absolute value can be written as a piecewise function, which is this. It has different pieces. So we have 3x minus 4, and then we also have the negative of that. And we use this one if x is bigger than or equal to 4 over 3. And we use this one if x is less than 4 over 3. Now, if this number sort of came up magically to you, it's actually where this equals 0. So I just say, well, when does the absolute value of x minus 4 equal 0? Well, it doesn't matter if I have the positive or negative. I just solve for x because the sign doesn't matter on 0. So then we get 3x equals 4, and now x equals 4 over 3. Okay, so now I've checked, I've got this. Now let's actually just go through and see if we can make this equate. So now I have 3. I'm going to check my case 1. So I have this 3x minus 4 equals negative 3. So I add 4 to both sides. So I have 3x equals, in this case, positive 1. And now I have x equals 1/3. Okay, well that's kind of weird. It's showing I have a solution. What if I did my other case? Let's say case 2. And that's when negative 3x, I'm going to multiply this negative through, so it's negative 3s plus 4 equals negative 3. So now in this case I want to isolate again, solve for x, and that is negative 3x equals negative 7, which is x equals 7 over 3. Okay, so I have two possible solutions, but I know right from the start there is no solution. So what does that mean? Well, it's telling me that if x is 7/3, which is bigger than the condition that I have set for this, so when we use this case 2, the solution that gave us, the number that gave us the solution wasn't inside the domain of this piece. And the same happens here. X is 1/3, and that's less than 4/3. And we need x greater than. So if we just graph this really quick, okay, so I have here negative 4, and then at my point of reflection, that is, say, 4 over 3 right here. And this is kind of the first, well, this is the first line. This is 3x minus 4. Now if I graph this line, I have positive 4. And so these are two lines, but I know that the positive side is the only side I care about. So this says when I'm greater than 4/3, I use this equation, and when I'm less than 4/3, I use this equation. But if I had 1/3 and I put it in here, what's my output? Well, I just have, yeah. So in this case, we can also say that at negative 3, there's this line that goes across, and we want to know when it equates to that. So here at 1/3 is when it intersects here, and when it intersects here is at 7/3. So this solution intersects at -1/3 on a part of the graph that doesn't exist. So this is y equals -3. And that's this part. So there is no solution because there is no intersection of this with this. So if y equals -3 and y equals the absolute value of 3x minus 4, there is no real solution. These solutions live outside. So hopefully that makes sense. It should make sense.